Today we are going to talk about the interior structure of the Earth or interior of the Earth. It is very difficult to have the accurate knowledge of the constitution of the Earth for the simple reason that the huge size of the Earth, that is if you see the radius of the Earth, that is about 6,370 kilometers, and considering that size, it is not possible to understand the interior of the Earth by any direct observation. So it is almost impossible for any kind of physical apparatus or any equipment or any gadget, to check the deepest, that is the part that is the center of the Earth. And though we do have some direct evidences, like there are, we have drilling or the boring, which can reach up to only a few kilometers only. So the indirect sources are used to understand the internal constitution of the Earth, and as you can see in the slide, these are the Earth's layers showing different parts of the Earth, that is the crust, the mantle, the outer core and the inner core. These are very, very elementary parts of the Earth, though there are much more details involved, in the constitution of the Earth, but broadly speaking, these are the different parts. Now, when we talk about the indirect sources, we have direct sources I've already spoken about, that the first direct source we take into account is the drilling into the Earth and the Kola super deep borehole that was done by Russia, that could reach only more than 12 kilometers, and that is supposed to be the deepest penetration in the Earth's interior. Considering the other direct source, that is volcanic eruptions, and as we know that in the volcanic eruptions there are super hot lavas which are ejected through the volcanic craters, and they tell us something about the chemical and the physical properties of the interior composition of the Earth. We can get to see the properties like, since it is a super hot lava, so it directly indicates the temperature of the interior. So these are the direct sources to understand the constitution of the Earth. Besides that, we do also have another source, which is the meteorites. Meteorites, they are understood to have composed of the original material from which the Earth was formed, and their composition range from metallic meteorites, which are made of iron and nickel, and there are some stony meteorites which are composed of the rocks like peridotite. Now, coming to the indirect sources, when we talk about indirect sources, we have to depend on the inferences which are based on the density of rock, pressure of the overlying rocks. That is also, in other words, it is called the superincumbent load, and the rate of change of temperature. So there are three things in indirect sources. I repeat, the first thing is the density of rocks. The second thing is the pressure of overlying rocks, which is, in other words, called superincumbent load. And the third thing is the temperature. Coming to the first point, that is density, as we understand that the average density of the Earth is about 5.5 grams per cubic centimeter. Now, that is the average density of the entire Earth, but as in the previous slide we had seen the broad parts of the Earth like crust, mantle, inner core, outer core. So accordingly, if we see, the average density of the crust is about 2.6 to 3.3, and the average density of the core is around 11. So that means there is an increase from the crust to the core, and this increase is, from the lowest density that is taking place or that is located in the crust and the highest density in the core. So the range is from 2.6 to 11, that is we say that the unit is grams per cubic centimeter. So when we talk about the pressure, it is due to the heavy load of the rocks which are overlying the crust, and that is why it is called superincumbent load. The high density of the core is very high pressure due to the entire load resting over it. Though we know that there is a critical limit, in each rock beyond which the density of rock cannot be increased despite of increase in the pressure. So the core is composed of very heavy, dense metallic materials like mixture of iron and nickel. It is also called Nephe, that is nickel and ferrous. Though we will elaborate on the properties, physical properties, chemical properties in the next part, but here we can understand that so far pressure is concerned, there is tremendous pressure on the core of the earth, which is the center of the earth, and which is supposed to be intrinsically composed of intrinsically heavy metallic materials. Coming to the third point, that is about the temperature, it is evident from the deep boring, as we just a little while back I talked about the deepest boring, say about 12 kilometers deep, and if we have even the evidence of volcanism, these are only the direct sources to tell us that the temperature increases towards the interior of the earth. And this increase downwards toward the center, that means from the surface to the center of the earth, there is a continuous increase in the temperature, and that the rate, if we talk about that increase, it is about 2 to 3 degrees Celsius for each 100 meters. Now, when we talk about the earth's crust, approximately it is understood as 30 kilometers thick, though the thickness of the earth's crust is different under the oceanic surfaces and under the continental surfaces. Under the oceanic surfaces they are thinner, whereas under the continental surfaces they are thicker, much thicker. So when we talk about earth's crust, it is the temperature within that, as I said, that it increases at the rate of 2 to 3 degrees Celsius for 100 meters, and as we talk about lithosphere, there is about 200 degrees Celsius to 400 degrees Celsius at the level of lithosphere. The temperature is around 1100 degrees Celsius at the depth of 100 kilometers in asthenosphere. As we understand as the students of geography, that first of all there is crust, lithosphere, and then asthenosphere. The temperature at the junction of the mantle and outer core at the depth of 2900 kilometer is very high, that is about 3700 degrees Celsius, and this temperature goes on increasing, and we can say that by the time it reaches the interface, the junction of outer core and inner core, it reaches 4300 degrees Celsius. So the maximum reach of this temperature, when we talk about the inner core, that is the center of the earth, it is as high as 6000 degrees Celsius, which is as hot as the surface of the sun. So here we are, in this diagram, we can clearly see that there is a cross section, which shows the interior structure of the earth. But if we see from the outermost layer, it is the hydrosphere, the atmosphere, the hydrosphere, in which there are continents and the oceans. And then in the Earth's crust, there are two types of Earth's crust. One is continental crust, which is more granitic in nature, and there is oceanic crust, which is more basaltic in nature. After that, there is, we can see here the asthenosphere comes, and then there is the rest part of the mantle, which is it is like plastic like composition, which is very hot. It is stiffer but not as rigid as the outer part of the mantle. Then comes the core. The outer core, you can see that it is liquid, whereas the inner core, that is solid. So here we have the clear idea about the different parts of the interior of the Earth. Now coming to the next evidence, indirect evidence of the interior structure of the Earth, that is very important, and that is seismic waves. Now seismic waves are the waves which are generated by the earthquakes. The earthquakes, in very simple words, it is shaking of the earth, and this shaking of the earth happens with any kind of a natural event like folding, faulting, or plate tectonics. It is caused due to the release of energy. That means the wave is due to the release of energy which is caused by certain natural event. These waves, they travel in all the directions. The source of the direction is called focus of the earthquakes, and the point which overlies on the surface of the earth, that is called the epicenter. So you must have heard that whenever there is an event of earthquake, it is estimated, or it is documented in the terms of the data which is taken by the seismograph at the surface, at the epicenter. So we can say that the layering of the earth, that can be inferred by using these seismic waves. And so far these seismic waves are concerned, the most important part of the evidence is the time of travel of these waves. Now we have to understand that these waves, as they are generated from the focus and they travel in all the directions, they either refract or they also at times reflect, and these are created by different densities of the different layers in the interior. The refraction is very simple, that when the any kind of a wave or the ray, when it changes its degree of travel or path, that is called refraction. And reflection is that the ray or the current or the wave, when it rebounds at the same degree, and that is called reflection. So here when we talk about the reflection and refraction, here we can say that earthquake waves are basically of two types. The two types of waves, number one, these are called the body waves. Body waves are generated due to the release of energy at the focus, and then they move in all directions traveling through the body of the earth. So by virtue of their travel through the body of the earth, they are known as body waves. Then number two, there are surface waves, and the surface waves are when the body waves, they interact with the rocks of the surface, and then they generate a new set of waves, that is called the surface waves. And these waves, they move along the surface. So we have the body waves and the surface waves. Now something what is important here to understand is that as these waves travel through the interior, their velocity undergoes change, and this change comes with with the fact that as they travel through different materials of different densities, then there is a change in their velocity. The relation is very simple. There is a direct relation: denser the material, higher the velocity. That means as the material of the rock or the interior structure of interior composition of the earth, it gets more and more dense, the waves, the earthquake waves passing through them also assume higher velocity. Now, as we just mentioned a little while back, that due to the refraction and reflection, their direction also changes, and they reflect and refract when again they come across different densities. There are two types of body waves. They are called the P and S waves. Number one, the P waves, they are also known as primary waves, and they are the fastest waves, and they are being the fastest, they move from the focus, they start from the focus and arrive at the surface at the maximum speed. These are called primary waves. The P waves are very much similar to sound waves. Their movement is the kind of vibration they have, it moves in a to and fro manner. They travel through all kind of mediums, that is the gaseous, liquid and solid materials. So these are the three type of the materials in the physical world: gaseous, liquid or solid, and the primary waves can pass through any kind of medium. Coming to the next point, that is the S waves, which are also called secondary waves. These secondary waves arrive at the surface with some time lag because they are slower than primary waves, and this fact that S wave can travel only through solid materials, because this is very important thing that they can only pass through the solid material. So we have these characteristics of P and S waves, which are quite important, as it has helped scientists to understand the interior structure of the earth. Now, the different types of earthquake waves, as we have understood, they travel in different manners, and as they move or propagate, they cause vibration in the body of the rocks through which they pass. P waves, they vibrate parallel to the direction of waves, and as a result, it creates density differences in the material, leading to stretching and squeezing of the material. The S wave, as I said, that they are the secondary waves, but they have a different type of movement, different than the primary waves, in the sense that they move perpendicular to the wave direction. That means they do create trough and crests, in the movement. That is like if you take the rope and you hold it at one end and start moving in a circular motion from the other hand, that will go in a way that it goes perpendicular to the wave direction. So these are the S waves. Now, so far the third type of waves, as we had talked before, they are the surface waves, which are considered to be the most damaging waves for the simple reason that they act on above the surface, that is the physical world, our our existence, that is over and above the surface is there, that is directly affected by the surface waves of the earthquakes. So here we understand that the reflection causes the waves to rebound, whereas the refraction makes the wave move in different directions. And their paths are also, they are in a way that these seismic waves, they never follow a straight path. They always follow the curved path, and that curved path movement is due to the refraction. As the different layers of the earth are concerned, or in fact, when we talk about the varying densities of the interior of the earth is concerned, so as the waves intercept the different densities, there is a change in their direction, and gradually as they keep refracting at every point of change in the density, they start assuming a curved path. So here we have this diagram where we say that the seismic waves do not follow straight path, rather they follow curved path, because there is a change in the densities of rocks in the interior of the earth. We can see in this diagram clearly that there is a focus of earthquake, and from there are two colors. One is red color that represents the primary waves, and there is blue color that represents the secondary waves. And we can also see the third type of waves over the surface, that is the surface waves. Now you can see that from the focus, these waves, the body waves, they are propagating through the body of the earth, and but we can clearly see here that the red color waves, that is the primary waves, they are able to pass through the earth, whereas the blue color waves, that is the secondary waves or the S waves, which are only able to pass through the solids, they are not able to penetrate through the liquid outer core, and that shows their limitation. So here we have both the types of waves in this diagram. So coming to the next very important factor, which is known as shadow zones of the seismic waves. Now when we talk about shadow zones, there are some specific areas where these waves are not reported, and therefore these zones are called the shadow zone. Now one thing one should remember, that when we talk about shadow zone, this is in reference to each set of waves. That means every event of earthquakes, there is a specific focus of that earthquake, and in relation to that focus there are shadow zones. That means there are no fixed shadow zones over the earth, rather it is subject to the incidence of the focus of the earthquake. So we have these shadow zones of body waves. That means both the body waves, that is primary and secondary waves, they have their own shadow zones, and these shadow zones give us direct information about the materials in the interior of the earth. It is observed that the seismographs, which are located at the surface, that is at the epicenter, they have they show that the recording of the arrival of both primary and secondary waves, they indicate some kind of shadow zone. That means the seismograph, which is located beyond 142 degree from the epicenter, they record the arrival of P waves but not that of S waves. So if I elaborate on this point, at any epicenter, if we see the there is a zone of 103 degree to 142 degree. In that particular zone, there is no primary wave recorded, whereas after 142 degree, primary waves appear again, but secondary waves do not appear again. That means the shadow zone of primary waves is from 103 degree to 142 degree, whereas the S wave has its shadow zone even beyond 142 degree in the earth. So we have the shadow zone of S wave is much larger than that of P waves, and so much so that if we see the larger extent of S waves shadow zone, they are even little over 40% of the earth's surface. So these two type of shadow zones are very important. Now the entire zone beyond 103 does not receive S waves. The shadow zone of S wave is much larger than that of P waves. One can draw these shadow zones for any earthquake provided you know the location of the epicenter. So when we look at this diagram, which shows the shadow zones of primary and secondary seismic waves, I can explain you here that on the top we can see the epicenter. Epicenter is the point which is located right above the focus of the earthquake waves. From the epicenter, we can see that the waves are moving in all directions, and that is these are the body waves, since they are traveling through the body of the earth. Primary and secondary waves, that is P and S waves, the movement of these waves can be seen in all the directions till it reaches the core. In the core, we can see there are clear-cut two parts, that is the solid inner core and the liquid outer core. Now the waves, we can see that when they intersect the boundary of the core, at that point they move inwards. There is refraction is taking place at the interface of mantle and core, for the simple reason that the density has striking difference at this point where the mantle stops and the core begins. So due to the sudden difference in the densities, there is a refraction in the waves, and due to the refraction we can see that the waves are moving inward at a different angle. There is a change in their angle, and in this refraction, or as we see that as they are passing through the core, it is only the yellow waves which are the P waves. We can clearly see the black lines or the black arrows or the black waves which are representing the secondary waves. They are not featuring in the core. The reason is very simple, that we can see here that the outer core is in a liquid state, and as we had just discussed that the secondary waves cannot pass through the liquid and gaseous mediums, and they can only pass through solid medium. Therefore, as the liquid outer core happens, the secondary waves stop. They do not pass through the core, whereas the primary waves continue to travel through the core, but at a different angle, because the refraction has taken place at the point where from mantle they are entering the core, that is the outer core. Then again at another point when they enter from outer core to inner core, again you can see that the angle of the waves are changing. that means again the refraction is taking place, and as they come out of the inner core and pass through the outer core again, the refraction happens once again, and it happens yet once again when it passes through the outer core into the mantle. So here we can see that as we can see the series of waves, they are one by one, they are traveling and passing through the interior structure of the earth. The point at which the refraction has taken place at the entrance of the core, that creates a gap which is shown as the shadow zone, in the diagram, the P wave shadow zone and the P wave shadow zone again on the other side. The measurement of these shadow zone, as we have talked about before, many references they quote 103, but approximately it is 103 or 105 and up to 140 or 142 degree. So here there are no primary waves, direct primary waves in the shadow area, where it is between 103 or 105 degree to 140 or 143 degree. The point which is worth noticing here is that P wave shadow zones are clear, but if we see beyond 105 degree in this diagram, there is no direct S waves or secondary waves. That shows that the shadow zone of the secondary wave is much larger. It lies between 105 degree or 103 degree to the other part of 103 degree or 105 degree. So this entire range, it shows that there are no direct S waves. In this comparative diagram, you can see the shadow zones of P and S waves. I repeat that here we can see that through the epicenter, the red color primary waves, they are starting and they are traveling in different direction in curved path, and as they enter the core, they refract and the angles change. As they pass through the core, again they come out in the mantle, again the refraction takes place, and that is how the shadow zone of primary wave is created. In the other diagram, where we can see that this is the shadow zone of the S waves, one can see that beyond 103 degree, they do not reappear again, for the simple reason that they are not able to enter the core, for the simple reason that the core, outer core especially, is liquid. So due to that constraint or due to that characteristic that they cannot pass through the liquid medium, they stop at that point, they do not get the entry into core, and therefore there is no question of their reappearing through the core. So the shadow zone of S wave is much larger, and as I had mentioned before, that it is almost 40% or more so far the S waves are concerned. So when we conclude, on the basis of the direct sources and the indirect sources, we understand that the structure of the earth is divided into layers, and these layers, they have they are physically and chemically different from each other. There are the seismograph, when the seismograph records the data of earthquake, it discovers that as the vibrations they undergo or rather they go through these layers, they undergo changes due to different densities of these different layers. As I have told you before, the different layers are like crust, the mantle and the core. So these three layers, they have different densities, and due to those different densities, they are supported by the record of the seismography, and that shows that the earthquake vibrations, they undergo change through these layers. Another important thing as a conclusion is that the earth, as I said, that it has a solid layer called a crust. Then after crust there is yet another layer which is highly viscous, and that is called the mantle, and then there is core, which is distinctly divided into two parts, that is the outer core and the inner core, whereas the outer core is a liquid layer and the inner core is a solid center, that is the inner core, or that is the center of the earth. So with these observations, we will take up the details or the characteristics of these three layers, that is crust, mantle and core, in the next part. Thank you.